Hey there, welcome back to the Andromedoom devlogs, episode number 5. If you'd like to skip ahead to the content, please check the timestamps in the description below. In the last episode, we set up the instantiation of object, that is the projectiles created by the player. In this episode, we're going to look at object destruction, how to handle that, and also some C# concepts of object-oriented programming, things like inheritance, composition, interfaces in this context. So we're going to be setting up the Space Invaders style shields and handling player, projectile, and alien destruction. And in today's devlog of the Andromedoom main project, I'm going to be showing you the 4 player ships that I've pulled together for the Asia Pacific region. That'll be coming up straight after this tutorial. Alright, let's head over to the screen. Alright, this is where we left off last week. I'll just give a brief rundown of some of the changes that I have made behind the scenes. They're nothing major. So last week we looked at the 3D physics collision layers. This is under the general tab of project settings, underneath the layer names group and 3D physics. And so I just added 2 extra groups. One is the 2 extra layers. One is the alien layer and one is the buildings layer, which are the shields. And I set up the scenes for those 2 extra objects. So first let's take a look at the projectile, which we wrote a script for last week, a simple one. Now the projectile is a member of the projectiles player layer, and it collides with objects on the alien layer and the building layer. So the player projectile damages aliens and your own shields, like in this Space Invaders game. Now we don't have to create a separate scene for the alien projectiles. What we do is we change this dynamically based on if the projectile is emitted from the alien or from the player. And the other scene I've set up is the alien scene. Now keep in mind, these are both kinematic bodies, which means they're movable objects that are not subject to physics forces. And if you look at the alien collision object, again, it's a member of the aliens layer and it collides with the player projectiles and buildings. And so the children of this node is just the mesh here and a box collision shape. And finally, this is the building. Now note, the buildings themselves don't move, but I did make it of the type kinematic body. And this comes down to the code architecture, because I will be favoring, in this context, inheritance for damageable objects over composition. But I will be showing you the approach that you can take using both techniques. And so again, this is a mesh. Now it might seem like a simple cube, but there's a reason for this that you'll see later. And a box collision shape. Now this building scene is packed into a group of 9 individual building scenes into another scene called the building cluster. And so if we look at the main level, we've got instances of the building clusters that function as the shields. And what I'm going to do is just add an alien scene up here as well. And pull this here. Now where we left off last week is we just created a function, a player fire script, which instantiates a projectile that moves upwards. Now this projectile moves upwards indefinitely. It doesn't remove itself after a given time. So that will be our first step. But before we do that, we have to think about how this is going to scale. There's 4 interactable types of objects. There's the player, there's the aliens, there's the buildings, and the projectiles. And all 4 of them all take damage. So we don't want to rewrite code for taking damage and for the destruction of these objects under each individual class. So there's 2 ways that we can do this. The one way is through composition, where we create a class called destructible, for instance, and then every object that is damageable will instantiate a copy of that class. So I'll show you how to do that first, because I think this is a bit more difficult to understand, a bit more abstract than inheritance, though it is quite favored in object-oriented programming over inheritance. So let's head over to our scripts folder and we'll create a new script. Let's change this to destructible and we'll create. Now destructible doesn't need to inherit from anything. So what does the destructible class need? It needs a integer that keeps track of health. So we'll call this private integer health. We'll use the underscore notation here and we won't initialize it. And it needs two functions, public void take damage, and it takes an amount of damage. We subtract it from the health. And then we say it's less than or equal to 0. We destroy the object. So now we do the destroy method. So what do we do here? Well, we need a way to communicate with any class that instantiates this class. And in the destroy method of this class, any class that is composed by it gets destroyed. We go private node and we'll call this parent. And then in the destroy function, parent, and we use the QueueFree method, which frees the node once the frame is complete. So now what do we do about these two fields? How do we know what to set them to? Destructible is never going to be instanced on its own. It's always going to be a part of another class that instances it. So what you do is create a constructor. And in that constructor, you pass two arguments. The parent and the health of the main class. And then you set the fields of this class to the arguments passed in. And the parent field is the parent argument. So now this projectile, see at the moment it's just traveling upwards forever. What we want to do is delete it after a certain period of time. So let's create a field called lifetime, and we'll free it after half a second, just so it's clear what's happening. And we'll also set this to 2 seconds. And let's print things to the console so we know what's happening. And we need a way to keep track of the elapsed time. So private float elapsed time, which will start at 0. It's not strictly necessary to write 0, but we'll just type that for now. And now we need to instantiate the destructible class. So destructible, and at runtime, a new destructible, and we pass in the parameters. Now the parent node is going to be this node, and the health, well in this case projectiles don't really have health. So we will just set the health to 1. And whenever the projectile wants to get destroyed, we'll just pass in either the take damage function or directly call the destroy function. Okay, now in the physics process, we increment the elapsed time by delta, which is the time increment of from the last physics frame. And then we say if elapsed time is greater than the lifetime, we call the destructible function. Well, we can either take damage or just destroy, and I think we'll just destroy it in this instance. Yep, and as you can see, the projectiles disappear after half a second, and on our console logger, we can see that the destroy method was indeed invoked. Okay, so now the projectiles disappear after a lifetime. Now we need them to destroy the aliens. So let's create an alien script. Oops. We'll head over to the alien scene. So head over to alien and attach a script. I've already done that. Okay, now it inherits kinematic body, and we need it to be destructible. So destructible, and in the ready function, we'll set destructible to a new instance of destructible. And so the parent node is this, the alien, and the health, we'll just say the health is 1 for now, so it gets destroyed instantly when it collides with the projectile. So now this projectile has its own destructible instance. It moves and it collides, and if the elapsed time is greater than its predetermined lifetime, we destroy the object. But now we need it to collide with objects that are destructible. Now this move and collide function here doesn't just move, it actually returns a class object of type kinematic collision, which is just a data wrapper of all the information on any collisions that the object would have made when it moved. So we can actually store this information in a variable. We'll call this collision info. And so we check to see if, first of all, if this is not equal to null. Because if it is, it'll just throw an exception if we try and do anything with it. So if it just moves and it doesn't collide with an object, that's going to be null. And we want to, but if there is a collision, we can access the object that it collided with using the collider property. But what are we checking for here? And this is the problem. We don't actually have access to instances of classes that other objects create. So we can't say if collision.collider has some instance of the type destructible. Not directly anyway. So you solve this problem using interfaces. So let's go back to Godot, and what we'll do is we create a C# interface called iDestructible. And what an interface does is it just guarantees that certain methods or fields exist on an object without enforcing a certain code. So we change this to the type interface. We want them to have a method called takeDamage that takes an amount, and a method called destroy. And so the alien class would also inherit, well, it would implement the iDestructible interface. And so the alien object would implement the iDestructible interface. And you can see that we've got a red underline here. What this is saying is that we don't have an implementation for the take damage and the destroy functions. So we're forced to do that. And so when we take damage, we actually call the destructible take damage method and pass in the amount. And similarly, for the destroy method, we pass the destructible.destroy method. And so in our projectile script, when we check if there's a collision, we check if the collider that we collided with is of the type, if implements the iDestructible interface. And we'll call it something, collided object. And what we do here is we say collide object, take damage, and the amount, I created this earlier, damage value. For projectiles, it'll just be 1. So the projectile will move, it will keep track of collision info, if there is a collision, and if it's a collision with an object that is destructible, we'll call the take damage method on the destructible object. In this instance, we've just implemented it for the alien. So when we do the take damage method for the alien, what it does is it actually goes to its destructible class instance and calls the take damage method on that, and passes in the amount. And in this case, because the health of the alien is 1 and the damage of the projectile is 1, the destructible class will call the destroy method in here, and so the alien should be freed. Let's test it out. So there's our projectiles, and there we go. You'll see here object took damage, so the take damage method was indeed called and then it got destroyed. Now in our projectile method, we'll also want to destroy the projectile, and so we can just say destructible.destroy. And there you can see that both objects got destroyed at once. And that's basically the basics of composition and how to use interfaces with composition. It can be a bit tedious because you'll have to instance that class every time you want to use it, but it does allow for code reuse. And of course you can implement other types of destructibles that don't necessarily use this class, but you still want to use the iDestructible interface. Or similarly, you can write your own custom implementation here. It just depends on your purposes. Now the reason this is advantageous is we don't need to worry about what type of object it is based on the Godot type hierarchy. Could be a spatial or some other kind of node can also implement the destructible interface and then create a destructible class. But if we were to use inheritance, which I'll show next, the superclass that is inherited from would have to implement a type here, which is why earlier I set the building type to kinematic body, even though it doesn't move, because the three other objects, the player, the aliens, and the projectiles, are kinematic bodies. They do move. So if all of them are going to inherit from a superclass, they would have to all be the same type. And this is one of the fundamental issues with inheritance. So let's modify our destructible class. And this time we'll build it using inheritance. So destructible, and in this instance, we inherit from kinematic body. So we don't need this one here anymore. We actually don't even need the constructor. And then we'll say QueueFree. So you keep the same methods. A take damage method, just reduce the health amount, the health by the amount. Health is 0, destroy, and that just QueueFrees your object. The only thing you need to change here is the health from private to protected. This way that any object that inherits destructible can override their health value. So we'll default this to say 1. This alien class no longer needs this line of code, or this. What it does instead, inherits from destructible. And so take damage no longer needs to be implemented. We no longer need this one, and we no longer need this one. Let's go over to projectile. We no longer need this code, no longer need this. Now projectile will be of the type destructible, and here we can actually keep our interface. And in the destructible class, we can say that it implements the destructible interface, which it does. It specifies the two methods. So this line of code here is still valid. Is destructible collided object. Collided object take damage, damage value. So we've removed a bunch of lines of code. Now hopefully things still work. But we can see that the projectiles are still freeing themselves. Let's look at the alien. And indeed the alien took damage and got destroyed, as did the projectile. So all the code still works, and we've actually saved a few lines. Let's take a look at the building object and get that to work. So let's attach a new script. Scripts building, and we want it to inherit from destructible. And the last thing we do for our destructible class is update that private field. Earlier is fine for it to stay a field because no other class could access it. But now because we're inheriting from destructible, all of the inherited members need access to that value. So we change it from a private integer health field to a protected integer health property with a getter and setter. And protected just means that it can be accessed by its inherited classes. We head over to our building script. Let's export a health value. What we do is we set our health property to our health field here. So as you can see, the shields now get destroyed once they're hit 3 times. Just like in Space Invaders. But now we need a visual cue to know that the shields have been hit. Now I haven't done dynamic mesh destruction in Godot, and it's something that I want to explore in the future. And if I pull it off quite well, I'll definitely make a tutorial about it. But the way I did this in the prototype was actually just to create 3 different meshes. So the way I did this, because I modeled everything in Magic of Voxel, I actually created 3 different meshes. So one is the full building in full health, one is half damage, and one is heavily damaged. So it goes from 3, 2, 1, and once it takes the 4th hit, then it's freed. To do that, we just create a mesh array on each building with the health states, and every time it takes damage, we update the mesh. Here we'll export, say, a mesh array called meshes, and here we override our take damage function. But to be able to do that, we're going to have to mark it as virtual. There we go. And what we want to do is actually call the base take damage function, which means that we update our health value first. If our health is equal to 0, we don't want to update the meshes. So we'll just return. Now keep in mind, even if our health reaches 0 in the take damage function, the destroy function that's called is QueueFree. So the node will be freed at the end of the frame, but all of this code will still execute. That's the difference between the QueueFree and the free method. We need to update the mesh. So we need here a field called mesh instance. Mesh instance. What this is it's a reference, this child node here. So in the ready function, we update mesh instance get node of type mesh instance, and the path to this node, this instance, it might be better to get the child. So there's two ways to do this. One is mesh instance get child, and so 0 just means the first child. And the other way is using the get node. So rather than passing an index, you pass in the path to the mesh based on the hierarchy. And so in this instance, it just means find the node building mesh underneath this node, which is here. So it's up to you what you want to use. One requires you to keep track of the naming of your scene hierarchy. The other just the order of the hierarchy. It's up to you. Here you've got an array of meshes. You'll want to specify a size here. So of size 3, and so you'll see we've got 3 mesh slots here in the array. So for number 2, I've got the full size. For number 1, the half crumpled, and for 0, the fully crumpled. And so what we do here is we go to our mesh instance, dot mesh, the mesh property. So strictly speaking, what we're updating is this property here of the mesh, by taking one of these meshes and passing it into this node here. And so the number of the mesh, we go to meshes, and what we're doing is passing the health value -1. Because at full health it's 3, so full health is 3, and this is the mesh at full health, which has an index of 2. If we take 1 damage, the health will be 2, so we're passing the mesh at index 1, and if we're on 1 health, after we've taken 2 hits, we pass in the mesh at index 0, which is why this works. So let's test this out. Just like Space Invaders. Keep in mind, I made a small mistake here. Make sure to not put a slash there. If you put a slash there, it will go to the top level hierarchy and start from the root. So if you omit that slash, it will start from the node. Okay, so we've looked at how to destroy objects. Let's take a look at object pooling. Now C# is garbage collected, which means once the memory usage reaches a certain threshold, the garbage collector is called, and any objects that are no longer being used get freed from memory. Now, I'm not sure how necessary this is in Godot, because GD script itself doesn't have a garbage collector, and so there's no need to worry about things like object pooling. That's the common wisdom. So I'm not sure if this still applies if you are building in C#, but this will be a fun exercise just to see how you would build object pooling in C# with Godot. And I'm going to use the generic Q data structure. Now I profiled this and I didn't see much of a difference, but that could be just because the project is so simple. So use your own discretion. Pushing out projectiles, you can see the number of objects goes up and you get spikes. Look, they're not noticeable at this scale, and it's a good practice not to optimize early and worry about optimization later once your project scales. So let's implement an object pool using a queue, and we'll see if there's any changes here. So we need a class that contains this queue. Let's put it on the level manager node, just for now. We'll attach a new script, and let's call this script, I'll call it object pools. And we'll add the systems.collections.generic namespace. So we'll export a packed scene. We'll call it projectile scene because we're pooling projectiles. And we'll set up an integer called the pool size. And in the ready function, we'll create a for loop. And in this for loop, first we need the queue. So we will create a queue, which is public queue of nodes, and we'll call this the projectile pool. So in the ready function, and here we'll take our projectiles pool and queue an instance of the packed scene. Now let's go to our player fire node, and we'll want a reference to the pool. So object pool, and in the ready function, we'll set pool to get off the root level manager as object pools. Now, when we instantiate a projectile, all we're doing is dequeuing it from the pool. Cool, so go to pool dot projectile pool dot dequeue, and let's print the size of this queue every time we press fire, just so we keep track of what's happening. And we'll instantiate the node as a projectile. So instead of instantiating a scene, we're just dequeuing it from the pool. But now we have to handle destruction. Now this inherits from the type destructible, so it already implements destroy, and we don't want to reuse any of the functionality destroy function because it frees it from the hierarchy, and we don't want that. So what we want to do instead is we use the new keyword, so we completely override the function. So in this new destroy function, what are we doing? Well, we don't want to free it, because that will completely destroy the node and we'd have to instantiate it again. So instead, we're just going to remove it from the scene tree. The way we do this, we actually need to get the parent of this node. And so from this projectiles parent, we call it remove child method. And the node that we're passing in is this. Now, once we remove it from the scene tree, we got to put it back in the queue. Let's test this out. I forgot to add our projectile scene. And we'll set our size to 10. We should probably initialize a value. Okay. And now we can see the size of our queue here. So the fire method is being called, but our projectiles aren't appearing. Don't fret, because I debugged this off camera. What's actually happening is, because this object is not actually being destroyed, it's actually being sent to the queue, this elapsed time is not reinitializing. So it is actually being created, but immediately being destroyed, because the elapsed time was still accumulating until it was removed from the hierarchy. So I guess there are a number of ways to fix this. Simplest way maybe to just make this a property, and then on the player fire we can set the elapsed time back to 0. I'd have to do some proper profiling to see if there's an improvement here. It's probably not at this scale, although the physics process does look like it's doing a bit better this time. I'd have to do some proper profiling to see if there's an improvement here. It's probably not at this scale, although the physics process does look like it's doing a bit better this time. That's a simple way of doing object pooling. There are a few things you need to keep in mind. As I was holding down the spacebar, the absolute minimum number of projectiles in the queue was 6, which means the amount of 10 isn't actually strictly necessary. What we can do instead is, instead of instantiating this pool, go to the player fire and check to see if there is a projectile ready on the queue. And if there isn't, then we instantiate it. So we go check if pool dot projectile pool. I guess we can say count is equal to 0. And if it is 0, we can take this line of code that we had earlier and paste it here. But we'd have to remove the variable keyword here, because we don't want to create a local variable within this if statement. So if there's no projectiles in the projectile pool, so that is if the count is 0, instance the scene. else execute this code. So let's comment this out and give that a try. Now, if you hold the spacebar down, it might not look like that it's working, but indeed it is. See, if we stop holding it down for a while, you can see that all of the projectiles that were fired indeed queued up back to 3. And it's counting down 3, 2, 1, 0, but it never instantiates more than 3. So this is a more efficient way of doing things. And as a result, we can get rid of this code. And this thing, and indeed, this pack scene as well. So now we only need to specify the pack scene under the player file. I guess it's up to your discretion how best to build the architecture of your project. So one last thing to clean up this code. We notice that when we instantiate this projectile, we're updating its elapsed time in this class, which is not really good practice. So let's get rid of this line of code, and instead of using this property, let's change this back to a field. I only did that earlier just to explain what was happening. So we can get rid of this. Oops, I should have renamed that token, that symbol rather. Rather than updating this in the ready function, we call it in a different method called enter tree. And this method is called every time it's added to the scene tree. Remember, when it's removed on the destroy function, and it's added again here. So when we enter the tree, we set the elapsed time back to 0. So let's, in the physics process, let's print the elapsed time, and we'll only fire one projectile just to explicitly see that it is being reset. See, it disappears after a second, and if we fire it again it disappears after a second. But keep in mind, this is the same projectile because it's going back into the queue. I think this will conclude the coding, but I just want to have a couple more words about inheritance. So now this projectile uses the new keyword to override. I mean, we could have just worked with override as well, because we're not calling the base method. But this is because in this project there's only one object that needs to be pulled. But as a project evolves, you probably want to create some kind of factory that builds object pools as an object that you want to be pullable is created. And so the way you can do this, for example, is if you load a different type of projectile, you can check if pool.projectilePool includes some kind of pool with a generic type of that object that you want pulled. And if it doesn't exist, then you can create a new one in this class. And all of them will have the same functionality. So rather than being freed, they would be removed from the scene tree and then enqueued. So what you want to do in this case is create a new type of class that poolable objects would inherit from. So you might call it public class poolable, but what you would do is still inherit the destructible interface. And so you must implement a method of take damage, which is the same, but and the destroy method. So the destroy method for the poolable type would be to remove the object from the tree and then figure out a way to enqueue it and generate queues on the fly for the particular types that you are creating. And this is another way of demonstrating the purpose of interfaces, because destructible and poolable behave the same sort of way. They both take damage and they both get destroyed, so they've got that same abstract behavior, but the implementation of this behavior is quite different. But when a projectile collides with another object, it doesn't really care if the object is pullable or if it's destructible using the free method, if it's freeable or if it's pullable. All that it cares is that it implements a method called destroy, which is why we use interfaces. Alright, thank you for watching. This is quite a long one, but I thought it would be a good opportunity to showcase how object-oriented programming, the basics of it, work in C#. You know, things like position, inheritance, interfaces. Hopefully you took something away from that. And I showed you how object removal works, how object pooling could work, one method of that, and also how to update meshes at runtime. In the next episode, I will be coding the alien AI using a finite state machine. I need to figure out how to do that next, and then I'll present a tutorial on that. In the prototype that I built earlier, it was just a bunch of if statements. Because the AI is simple, it's not a big deal, but it would be a good opportunity to showcase that sort of programming behavior. If you enjoyed this video and you're enjoying the series so far, please make sure to hit like and subscribe and hit the bell as well. Leave any comments, questions, suggestions in that box down below. Stick around if you'd like to see the progress on the Andromedoom main project, where I'll be showing you 4 player ships the one that you start with and the 3 that you can unlock in the Asia Pacific region. That's coming right up. Alright, let's take a look at the player ships. So you start with this standard issue, I'm calling them the Fossilators. So the theme for the Asia Pacific region's player ships is also diesel punk like the aliens, but they're based on dinosaurs, land-based animals instead of sea creatures. Fossil fuels is the theme, basically. So the first one is based on the original Space Invaders pad, and it looks just like a tank with its cannon and its turret, you know, pointed upwards. It's got a few splashes of red paint because the theme is supposed to be red for these ships, though I'm not sure how well I conveyed that across with the color scheme. But as you can see, rusty metal all over the body of this tank. I am not sure, I'll discuss materiality in a sec. So the second one is the pterodactyl, and this will be a flying ship that hovers above the ground. So it can't duck underneath the buildings just like Space Invaders, but it will be able to fly around quite quickly. This is the Velocitractor, and this is the Stegonator. It's got that big rig looking engine at the front, engine up the back, which looks like the Stegosaurus tail spikes, and it's got 4 big cannons, which the outer 2 are slightly angled outwards, so it would alternate firing between each one. Now you'll see that I've got a 5th little doodle here, which looks like a Triceratops. I haven't decided whether to keep it at 4 or 5 ships, but because I'm quite behind on the program, I'm just going to stick to 4 ships for now and then add on content later. And the reason for 4 is, well, each region has 6 cities but 1 boss level, so 5 cities, and you'd start with 1, let's say, and then you can unlock the other 3 as you progress. But in particular, one way of balancing these ships is to look at different aspects and put them on a ternary plot, like a soil chart. Except this time it's 3-dimensional, so it's a tetrahedron. And so the 4 aspects are offense, so firepower, and in this instance the Stegonator would be the one with the most firepower. Handling, so how easily it moves and steers. In this case the pterodactyl would be the one with the handling. Standard issue would be just plain defense, so it doesn't handle too well, doesn't have much firepower, but it's got good armor. And the 4th axis is special abilities, and this will be in the form of what colored dots you'd have available to you, so you can apply custom weapons. And so for the first world, the Asia Pacific region, the Velocitractor will be the special abilities ship. Now you'll notice that there's different variants that I've rendered out in Blender of these models, and the difference between them is there a metalness to the material. Now looking at it in Blender isn't going to help much, so because it's going to look different in Godot. So I'll show you how it looks in the engine on my game main project. So here's a little lightbox scene with the standard issue tank, and I put up a white, blue and a yellow light just to see how things look. And so this is the texture with metalness applied, and you can see it most emphatically in this little ammo belt here, because that's where the roughness is very low and it's metallic. But metalness overall makes it look a lot darker. So if we were to switch off the metalness, see, there's not much of a contrast now between the dark and the bright spots. Everything looks a bit more even, which doesn't look too bad. It just really depends on what effect I think is going to look best in the final product when I put the levels together with their lights. Now there is one more thing that I can do, which is more extreme than this one, and that is going into the flags property here and clicking on shaded, and this completely removes any shading effect on the material, and so the colors that you'll see are the colors verbatim from the image texture, which doesn't look too bad in itself. It's quite charming. It looks like some old school graphics. So let me know what you think in the comments, see if you actually like this look. That's all I had for today's devlog. I'm going to be starting to chug along on the main project, which involves refactoring a bunch of my code, hopefully building the foundation of the project quite well so that I can scale with minimal headaches. In the next episode, I'll be looking at finite state machines for the aliens, and I'll update you on the progress on the main game with the assembly of the Asia Pacific region. So thank you for watching. Please don't forget to hit like and subscribe and hit the bell as well, and I'll see you in the next one. Thanks guys.